Hey, I'd like to welcome you to another episode of the Mission Matters Innovation Podcast, your source for all things innovation. My name is Adam Torres. You can follow me on Instagram at @AskAdamTorres to keep up with my book releases, book tour schedule, signings, all that other good stuff. Always love to connect with you there. And as always, if you'd like to apply to become a co-author of one of my upcoming books, just head on over to the website, missionmatters.com, and click on Become an Author to apply. All right, so today I have Dr. Ty Vachon on the line, and he's an AI consultant and advisor over at Aura Informatics. Ty, welcome to the show.
Thanks, Adam. Great to be here.
So excited to get into today's topics. We're going to talk about how AI can change radiology, but before we do that, I do want to go a little bit further into what you're doing over at Aura Informatics. So tell us a little bit more about the company, please.
Yeah, thanks very much. So I've been creating an advising and consulting firm working with small and large companies, helping doctors help patients.
That's awesome. And I think that's going to be a good transition, too, to get further into the subject of AI and what that can mean for radiology. So where do you want to start with that one?
So many people don't know what happens after they have a CAT scan or an MRI or an ultrasound. Many people don't know what a radiologist even does. So what I'd like to talk about is how computer vision is helping my field of radiology. When people post a picture on Facebook, they're very accustomed to Facebook saying, oh, is this Bob or is this Tom? And they are confident that that answer is correct. And so over the last 5 years, there have been many companies, well over 100, that are trying to apply this kind of image recognition to find things in our CAT scans, in our MRIs, or our ultrasounds.
So just to make sure I understand correctly, so like if you're a tag, so it's like being able to look at an ultrasound or look at the image and tag and say, oh, this could be XYZ right there, and to have the imaging to be smart enough to pick it out.
Exactly. And so for one example, let's say a woman is pregnant and we want to try and find something on the baby inside. An algorithm could be trained to identify the gender. That could be something that could be done. Now, at this time, there are 67 FDA-approved algorithms for AI in radiology. Now, that's not one of them yet, but it's not to say that it couldn't. They focus more on more emergent things right now, like blood in the brain on a CAT scan and things like that. But these are the kind of things that you can train an algorithm to find my face. You can train an algorithm to find anything on a CAT scan or an MRI or X-ray.
Man, that is so exciting. So what does that look like going forward then? And obviously, nobody has the crystal ball, but I just mean in general, numbers wise, I don't know, like mistakes, other things like that. As the algorithms get smarter, as there's more data fed into them, what do you think that looks like? It's super interesting.
So in the short term, we're hoping to make the radiologist job, safer, more efficient, more effective. That is the short-term goal. But ultimately, sure, in 2, 3, 4, 5, 10 years, there will be things that will be measured by the computer that I couldn't even see in the first place. And now it's able to make very specific findings and recommendations. And I'll just give one example that's happening right now that I love. There's a company that can look at multiple sclerosis plaques on a brain MRI. Now, these are very irregular shaped little things on the pictures, and it's really hard to measure these as a human being, but the computer can do a great job at that. And so if someone has multiple sclerosis and they use this MRI to evaluate it and they take a medicine, they can see if the medicine has a very subtle change in decreasing the amount of multiple sclerosis for that patient. That's something that humans just can't do, and this is a way that the computers can assist us in treating patients.
Wow, that's amazing. And so I do have to ask this side of the because there's always two different sides. How is the radiologist community kind of embracing and I know you're not the voice for everybody, but is there a consensus on this, on whether it's a good thing, it's a bad thing? How's that looking?
It's changed. About 5 years ago, there was a little bit of hesitancy. Could this be something gunning for our jobs? And as we've seen over the last several years, there's only 67 algorithms. To put in perspective, when I look at CAT scans and MRIs on a day's work, I probably need to know 20,000 things, let's just say. And so we have a long way to go for algorithms to do any significant part of my job. And in the short term, it's just going to help us answer really specific questions for specific patients. So you're exactly right. Like there was a little bit of hesitancy at first, but I think now there's an expectation for these things to kind of come along a little faster and see what they can do. So I think the ball is in the court of the AI developers to bring this to the radiology market.
I think it's exciting. I mean, because normally when technologies like this are introduced to different things, I found that it just expands the market. Like the technologies get better, there's more things that can be done. Sometimes prices go down. It just depends. And people are more able to more people are able to have access to the technology. Then, I mean, sometimes it has that expansion effect. Whether that does or does not, this field yet has yet to be seen, but it has in some others. What is on the hospital side and on the other side of it? So let's get into that part. Are they kind of receptive to it, or I mean, how does that chain of command work?
So slightly different, but along the same lines that you're going there is the whole reason why doctors get a CAT scan or an ultrasound or an MRI is to try and figure out what's happening with that patient. And so my job as a radiologist is to look at the pictures and formulate some sort of useful output. So I think medicine in general is very open to finding ways to collect data from a patient and getting usable output to help the patient on their journey. And so, sure, hospitals and doctors and departments all kind of fall under that, like waiting to see how this can be helpful. So my multiple sclerosis example is one tiny sliver of taking like a patient who has something that we can help with and how we can help with all of us collaborating together, the neurologist, the primary care, the radiologist, the pharmacy giving the medicine, and the feedback loop there. And so you can, cut and copy those things a million times or 7 billion times, a lot of times. And so it's very scalable once we start to figure out ways to help patients with this technology.
Man, this is exciting. I love it. I love having one of my favorite parts to do this podcast is having smart people out there that are working on problems in healthcare like this, or opportunity areas, I should say, in healthcare like this. Because hey, one thing's for certain, we're all aging right now. I'm like, when I need that one day, I wanna look at the chart and I want it to be just like Facebook. Like, you see that? You were tagged right here, and I'm like, oh man, tell me sure there wasn't a smudge doctor, but that's how I want it to be, that easy and that easy for people to understand. So I love it. I love what you're doing. I love the work. That being said, so Ty, if somebody, final question, two-part question. So if somebody's listening to this and they want to learn more about aura informatics, what are the right type of institutions to connect to learn more and that makes sense typically to work and get information from aura informatics? And what's the best way for them to reach out?
So I recognize that this is a little bit out there for most people. And so I really do make it a point on my LinkedIn feed to teach. So 1 to 2 times a week, I'm either finding another post or posting my own that's trying to bridge the gap between what most people know and what I think the future of medical imaging is going to present. So really LinkedIn, Ty Vachon on LinkedIn, pretty easy to find on there. And if you kind of take a look every once in a while, you'll see that I'm really trying to help educate people in this field.
Fantastic. Well, Ty, really appreciate you coming on the show today and sharing more about your background and all the great work you're doing over at Aura Informatics. And to the audience, as always, thanks for tuning in. Hope you got a lot of value out of this. If you did, don't forget to subscribe to the show. Leave us a review on the Apple iTunes Store. And if you're watching this on our YouTube channel, Mission Matters Innovation, definitely give us a subscribe there, but also leave us some comments on the video. Love to know what kind of projects and things that you're working on. And Ty, thanks again for coming on the show.
Thanks very much.